Hello, let us look at some matrices multiplication. So, on number 47, these are a few questions that I was asked from the homework. We want to multiply A, B, C, and then, all these six things. So, let us try to multiply A, B, C first. Then, when you look at it, A is 2 by, this is 2 by 1, 2, 3, 4. Now, B is 1 by 4, and C is 4 by 1. So now when you multiply ABC, then this has to multiply by this one. But the thing is then that means when this number of columns has to match with number of rows, but that doesn't match. So in fact, we cannot even multiply A times B. So anything with A times B cannot be multiplied. So this is out. A times B, that's out. So forth and so on. Now, then let's try to look at ACB. ACB is this one is multiplied by this one. So A is multiplied by C. So the inner product, the inner dimensions are matching here, 4 and 4. Then which will resulting in 2 by 1, and then 1 matches with the next inner dimension, 1 by 4. So it seems like we can multiply this one. How about BAC? Because A and C can be multiplied. How about B? So how can B multiply by A? So B and then A, when you look at it, inner dimensions will be 4 and 2. So they don't match here. Because first comes B and then followed by A. So 4 and 2, they don't match, so you cannot multiply them. So B and A cannot be multiplied here either. How about this one, B and C? B and C, oh great. 1 by 4 and then 4 by 1 can multiply. But then our result will be 1 by 1 in this case. That cannot multiply to 2 by 4. So this one doesn't work. Only thing that will work is this one. So let's try to calculate this one first. What is AC? AC is these four numbers has to multiply by these four numbers. And then we're going to be getting 2 by 1. So these four will be multiplying by these four. So 1 times 1 is what? So our answer should be 2 by 1. So 1 times 1 is 1. 0 times 0 is 0. 6 times negative 1 is negative 6. So far, 1 minus 6. And then negative 1 times negative 2 is 2. So we get 1 minus 6 plus 2. So what we end up getting is negative 3. How about the second one? These 4 has to multiply by these 4. So 2 times 1 is 2. And 0, 4 times negative 1 is what? Negative 4. And 0 times, so it becomes 0, so we get negative 2. So A times C becomes negative 3, 2. Now next, what we need to do is, we're going to multiply AC by B. Then we're going to multiply this one by this one. So that means my first row will be negative 3 times 1, negative 3 times, so negative 3 is multiplied to all 4 of them. So negative 3, and then negative 21, 27, negative 6. Next, what we end up getting is the bottom one. We end up getting negative 2 is multiplied to all those values here. So that means what we end up getting is negative 2, and then negative 14. Oops, let me just rewrite it. And then 18, and then we get negative 4. So that becomes our answer. So with that, you can see how we can multiply A, C, and then B at the end. But all the other stuff cannot be multiplied. All right, let's try to look at number 53. Now, in this case, this is another application of matrix. How a matrix is simply an array of numbers, as you know. And then one thing that which you can tell is you can see that these numbers can represent many different things. In this particular case, these values represent the darkness. of the color. So then, what I can do is, since I have uh, this digital screen, I could actually write it over on top, and then you know transpose that out later. So for example, first, what they want you to do is, they want you to write down they want you to represent this one digitally. So what we end up getting is something like this. I'll put it this way. So first one is 1, 0, 1, 0, 1, 1. Second one is 0, 3 because dark, and then 0, 1. This one is 2, 1. And the third one is 1, 2, 0, 0, 3, 0, 1, 3. This one seems to be a bit darker than this one, so 2, 3, and this one becomes 2, 0. And 0, 3, 0, 0, 2, 1, then 1, 2, 0, 1, 3, 1. So that seems to be our values of the matrix. Now find the matrix that represents the darker version of this one. So darker version is basically everything is increased by one shade. So this will be our first matrix. Now what I'm going to do is I'm going to bring this one over down here to answer B. I'm going to increase all the values by 1. Then that's how it's going to be darker image of this one. So we get 2, 1, 2, 1, 2, 2. And 1, 3 is still 3, cannot be darker than that. 1, 2, 3, 2. So you can see the point 2, 3, 1, 1, 3 stays 1. 2, 3, 3, 3, 3, and then this one is what? 1. And this one is 1, 3, 1, 1, 3, 2, and this one becomes 2, 3, 1, 2, 3, 2. So the red one becomes our answer. Then I'm gonna just pull out this green one out. All right, so that's basically how we can create a darker image. Now C, negative is obtained by the reversing the light and dark. So basically 3 becomes 1, and then 1 becomes 2, and 2 becomes 1, I guess. So that means I'm gonna try to use this platform one more time. And I'm gonna, maybe I move this one to the side. So I'm gonna use blue this time to C. So wherever there is 1, I'm gonna use, so I'm gonna just reverse the numbers. So this one now becomes 2, 3, 2, 3, 2, 2, 3, 0, 3, 2, 1, 2. Basically I'm adding to be 3, you know? So that kind of gets the reverse. So this one I need 2, 1, 3, 3, 0, and this one is 1. I mean 3. Oops. One more time. 1, 3, 3, 0, 3. Here, 2, 0, 1, 0, 1, 3. And then 3, 0, 3, 3, 1, 2, 2, 1, 3, 2, 0, 2. So that becomes, the blue one becomes the matrix that is the negative of the original. So what I have done is, as you can tell, I simply looked at these numbers and made it to be 3. So if I have 1 turned into 2 by simply subtracting 3 minus 1. That's basically what I have done. Now, D is to increase the contrast. 1 becomes 0 and then 2 becomes 3. So that means Now I'm going to try to redo that over here. I'm going to use the black ink. So I'm going to call that as D. So 0 and 3 stays as it is, but 1 becomes 0, and then 2 becomes 3. So I get 0, 0, 0, 0, 0, 0, and 0, 3, 0, 0, 3, 0, 0, 3, 0, 0, 3, 0, 0, 3, 3, 3, 3, 0, 0, 3, 0, 0. This one becomes 3 and 0, and then 0, 3, 0, 0, 3, 0. So that's what I'm getting. Now, oops. Okay. Okay, I brought this one out. And then the question is, does this clarify the image? It seems yeah, because let me just shade this one for you, kind of see what end up happening. I'm going to use the purple for 3, like representing the dark one here. Boom. These are 3s, and these are 3s. And you can see if you have letter H here hidden in this case, you know? So, so basically, like, you know, these are H's. That's what you end up getting. So that was kind of fun, you know, to see what was happening. Now let's look at E. Draw an image represented by this matrix I over here. And then can you recognize what this one is? If you don't, try to increase the contrast. So honestly, it's kind of hard to tell what this one is. So what I'm going to do is I'm going to increase the contrast. That might be easier for us to see. So what I'm going to do is I'm going to same deal. So 0, 3, 3, 3, 3, 0. And then 0, 3, 0, 0, 0, 0, 0, 3, 3, 3, 0, 0, 0, 3, 0, 0, 0, 0, 0, 3, 3, 3, 3, 0. The last one is all 0. All right, so it's kind of hard to tell here. So what I'm going to do is I'm going to highlight the 3's over here. Oh, what do you see? You see the letter E. That was what was hidden. That's kind of cute. All right, so that's how you can solve number E as well. Let's look at the next question. So powers of a matrix, you know, they want us to calculate a squared, a cubed. Basically, we just want you to continue multiply by a itself. So for example, I don't know what the answer should be, so I'm just going to do a squared. A squared, that means I'm going to do 1, 1, 0, 1, multiply that by another 1, 1, 0, 1. So let's see what we end up getting. Since this is 2 by 2, when I multiply these two matrices, I should be getting 2 by 2 as well. So these 2 is multiplied by these 2, we get what? 1. These 2 is multiplied by these 2, so we get 1 plus 1, we get 2. And these 2 multiplied by these 2, we get 0. The last 2, we get 1. Okay, so we get this one. Everything else was the same except this value. How about a cubed then? I'm going to say a cubed is a squared times a. So what I'm going to say is this is 1, 2, 0, 1 is multiplied by 1, 1, 0, 1. And let's see what we end up getting. These 2 multiplied by these 2, so we get 1. These 2 is multiplied by these 2, we get 3. These 2 is multiplied by these 2, so 0 times 0. And then these 2 multiplied by these 2, so we get what? 1. Oh, it's a little bit interesting. We see a pattern here. So when it was a squared, everything was the same except this number. When it was a cubed, same thing except this number. Just increasing this particular value more and more. Let's see if that's true for a sub 4. That means a sub 3 times a. So what I'm going to do is 1, 3, 0, 1 is multiplied by 1, 1, 0, 1. So these two multiplied together, we get 1. 1, 3 is multiplied by 1, 1. Oh, it's equal to 4. Oh, I see. These two multiply together, so we get 0. 0, 1 is multiplied by 1, 1. We get 1. Ah, so it seems to be that a sub n in this case is equal to 1 and 0, 1. That's what we end up getting. All right, so that's how we can do number 55. Let's look at number 57. So in this case, we are assuming that we're trying to find the square root of the matrix. And we don't know how to do it except to just multiply at this point. So what we're going to be doing is we're going to assume that the particular matrix that which we do not know is A, B, C, D. And then when I square that, it should be equal to this one. Hence, we should be able to figure out the square root of this vector. I mean the matrix. So first one, we'll say AB, CD, multiplied by what? AB, CD. It should be equal to 4, 0, 0, 9. And let's try to write up we should be able to figure out 4 sets of different equations here. So when AB is multiplied by AC, we consider first A squared plus BC has to be equal to 4. Now, second, AB is multiplied by BD. That means AB plus BD is equal to 0. In other words, B times A plus D has to be equal to 0. That's the second equation. Let's go for the third one. So, CA plus CD is equal to 0. So that means C times, this can be rewritten as A plus D. Oh, okay, we see something similar here, is equal to 0 as well. Lastly, CD is multiplied to BD, so we get BC plus D squared is equal to 9. Hence, we have 4 different equations here. Now, but I'm drawn to these 2 equations because they're set up to equal to 0. So my first case is what if B is equal to 0? Because that's an option here, right? If B is equal to 0, then we realize that A plus D has to be, it can be anything you want it to be. So if B is equal to 0, then I get to go back to the first equation here. We get A squared equals 4, so therefore A should be equal to plus or minus 2. Now, independently, here, when A is equal to, when B is equal to 0, then we get to realize that D squared is equal to 9, so we get D is equal to plus or minus 3. Now, based upon these 2 cases, no matter how we add A and D, it will never be equal to 0. So that means C must be equal to 0 as well. And then I think it works the other way around. If C is equal to 0, we can go backwards, and then you get to realize that B must be also equal to 0 as well. So that's one option. How about the second option? What if A plus D is equal to 0? That may be a possibility. If A plus D is equal to 0, then we get to realize that A is equal to negative D. Then one thing that which we get to realize is the very first equation and then the last equation. Because A has been squared and D has been squared, so these 2 equations should be equal to each other. So meaning this portion should be equal to this one, if A and D are negations of each other. But the values, when you're adding, the values are not equal to each other, so this is not even possible. There's a contradictory. These 2 are supposed to be equal to each other based upon this assumption, but you realize that these values that we see, numerical values, 4 and 9, they're not equal to each other. So therefore, This is not a possibility. All right, so then we have a few matrices. Bn, C has to be equal to each other, while A and D can be positive or negative 3. So we get A can be plus or minus 2, 0, 0, plus or minus 3. So therefore we have 4 of them going through this way. All right, so that wasn't that bad. How about the second one? So what I'm going to do is I'm going to copy this one. Let's go for the second equation here. So we're going to apply the same idea. So A, B, C, D multiplied by A, B, C, D has to be equal to 1509. Now, so then how are we going to do this? We're going to multiply same way as before. So first case, these two multiplied by these two. So then, in fact, the multiplication will be exactly the same. So I can parallel my first set of calculations exactly the same way as this one. So then, A squared plus BC should be equal to what? 1 in this case. So then here we get A squared plus BC should be equal to 1. And then second one is B times A plus D should be equal to 5. And then C times A plus D should be equal to 0. And BC plus D squared should be equal to 9. Now, only thing that that was equal to 0 was the third equation. So this is where I'm going to try to look at it. So what if C is equal to 0? Case number 1. What if C is equal to 0? Then we get to realize that first equation, A squared must be equal to 1. So that means A must be plus or minus 1. I don't know which one it is, but it would have been, I have these two options. And then likewise, when C is equal to 0, from the last equation, we get to realize that D squared must be equal to 9. Hence, D must be equal to plus or minus 3. But how about B? In order for you to find B, since A and D have 4 different cases, the value of B may change 4 different times. So I'm going to call this one as A, I'm going to call this one as D, and then I'm going to try to figure out what B value should be. So A can be 1, 3, 1, negative 3. Negative 1, 3, negative 1, negative 3. So we have these 4 choices. But when I add them up, multiply that by B has to be equal to 5. So then when I add up these two, it becomes 4. So 4 times B equals 5, then B must be 5 over 4. And the second one is negative 2, so we get 5 over negative 2, so that means negative 5 over 2. Thirdly, negative 1 and 3, when I add them up, it becomes 2, so we get 5 over 2. Lastly, it becomes negative 5 over 4. So in fact, we have these 4 choices. So in this case, we actually have to write them down. So we get, first one is 1, 5 over 4, and 0. C was equal to 0 in all cases. And then D was equal to 3. That's the first case. Second case is 1 and then negative 3. And this one is 0. We get negative 5 over 2. Third case, negative 1 and 3. Well, this one is a 0, so we get 5 over 2. Lastly, negative 1, negative 3. This one is 0, we get negative 5 over 4. So these are the square root of this matrix. Now, but that's only one case. Let's think about the second case. Second case is from here. What if A plus D has to be equal to 0? Then A will be equal to negative D. Then in fact, I'm going to go for the same argument as to this one in this case. In other words, if A and D are negations of each other, then I'm going to look at these two equations here. Those two equations are supposed to be equal to each other because B, C is a same term. A squared and D squared has to be equal to each other in this context. But the values, as you can see, are not the same, when in fact it's supposed to be the same if this assumption were to be true. So by contradiction, this shouldn't be possible. So therefore, we have 4 answers, and these are our solution. All right, with that one, I'm going to close up, and I'll see you later.